Hello, everybody. Today we are going through the 2020 November paper 1 mathematics question paper, and we will start by diving right into question 6. Question 6 is a financial math question. Let's get into the statement. On 31st January 2020, Tepo made the first of his monthly deposits. Okay, first thing you highlight, of 1,000 Rand. Okay, so immediately that tells you that in whatever you're doing, you know that okay, let's read the statement. Monthly deposits of 1,000 Rands into a savings account. All right. After making those monthly deposits, he continues to make monthly deposits of 1,000 Rands at the end of each month until 31st January 2022. So the first thing we highlight is the first date, monthly deposits of 1,000 Rand, and he continues to make monthly deposits of 1,000 Rands at the end of each month until 31st January. The interest is fixed at 7.5% per annum compounded monthly. Okay, so what will the investment be worth immediately after the last deposit? So immediately from the statement, you get that this is a question that requires you to use the formula for the future value of an investment. Okay, and from the statement, you can already tell what okay, let's write down the formula. The formula tells you that the future value of an investment is equals to the monthly deposits which is X, multiplied by 1 plus the interest to the power n because it's compounded, minus 1, all divided by the interest. Okay, so now the first thing that you're going to look at is monthly deposits of 1,000 Rand. Okay, monthly deposits of 1,000 Rand, that is your X value. Okay, we are told that it is compounded at 7% per annum compounded monthly, meaning your I is going to be given by your I is going to be given by 0.075 because 7.5% translates to 0.075 because that is 7.5 divided by 100. That is 7.5, which is equal to 0.075. Okay. So that it's going to be that 0.075 divided by the number of months for which it is compounded. Okay, and we can tell that it is compounded monthly, so that's going to be divided by 12. Moving forward, you find that your X is 1,500. We got that from the statement. 1 plus 0.075 divided by 12, all to the power. Now n is going to be the number of months that is between the 31st of January 2020 and the 31st of January 2032. Okay, and so that's 12 years, and in 12 years you have approximately 145 months. Yeah, so that's going to be n is equal to 145. Okay, minus 1, divide all of that by 0.075 over 12, and you find that your answer is 234,888.53. Wonderful. Now, you need to be careful when you're looking at the interest rate particularly, right? Whatever they tell you about the interest rate, you need to account for that. Unless if you are in a situation where you are told that the interest is compounded monthly, I mean yearly. If the interest is compounded annually, then it means that you don't have to what do you call it? You don't have to divide by anything, right? Because the number of months or the number of years in a year is essentially 1, right? So if it's compounded yearly, then if it's compounded per annum yearly, then you don't have to divide by anything. But if it's compounded monthly, you would have to come and divide it by 12. If it's compounded quarterly, you would have to divide by 4. And if it's compounded semi-annually, you would have to divide by 2. Okay, so yeah. Moving on to 6.1.2. If he makes no further payments but leaves the money in the account, how much money will be in the account on 31st January 2033? Okay, so now we are told that he makes no further payment. Okay, so because he makes no further payment, it means that we're not gonna use either the present value or the future value account formula, because those two formulas require the person or the person in the question to be making to be making equal monthly deposits into whatever account they are making the payments into. Okay, so in this case, because we are not making fixed payments at the end of each period, we can use the compound interest formula. Okay, so that is going to be A is equals to P, which is the principal amount, plus the interest to the power n. Now we know that the principal amount is the 234,888.53. 1 plus our interest rate is still the same. It's still compounded at 7.5% per annum, compounded monthly. So what's that going to be? That's going to be 0.075 divided by 12, multiplied by how many months are in a year, because remember, it's only in the account from 31st January 2032 up until 31st January 2033. So that is the space of a year. That tells you that n is equals to 12. Therefore, your amount at the end of the investment period will thus be 253,123.54. Great. And now moving on to 6.2. So for 6.2, we are told that Jim bought a new car for 250,000. The value of the car depreciated. Excuse me. The value of the car depreciated at a rate of 22% per annum annually, according to the reducing balance method. Okay. After how many years will its book value be? Will its book value be 92,537.64? Okay, so firstly, principal amount 250,000 given in the statement. It depreciates. Okay, the value of the car depreciate. So immediately that tells you that we need to be minusing the interest. Okay, we need to be minusing the interest. It depreciates at a rate of 22% per annum annually. That's very important. Annually. 22% per annum annually, according to the reducing balance method. So that immediately tells you what formula you need to use. You need to use the reducing balance formula. Okay. After how many years will its book value be? 92,000. That is our final amount. So what is the formula for our reducing balance? The formula for our reducing balance is the future amount is equal to the principal amount multiplied by 1 minus the interest, all to the power of the number of n. Okay, the number of months. So we know that at the end of the period, we will have the car must have a value of 92,537.64. The initial amount or the principal amount is 250,000. 1 minus the interest is 22% per annum annually. Okay, so that means we don't have to divide by anything in this situation. We divide by 1 because it's 1 year. Okay, we divide by 1, 0.22 to the power n. Okay, so from here we do simple algebra. I'm just going to write this in a nicer way so that it flows better. To the power n is equal to 92,537.64 divided by 250,000. Okay. Then from here, using your laws of exponents, if you have a to the power of n is equal to b, you can find that n is equal to the log to the base a of b. Okay. This is the law of logarithms that we will be using. So then that means that in this case, n is equal to the log of our base. This is our base, 1 minus 0.22 into 92,537.64, 250,000. And yeah, putting that into your calculator, you will find a decimal value. And if you find a decimal value, you need to round that off to the nearest whole number, because n is a whole number. N is the number of years or the number of months. So it needs to be a whole number, okay? So that means n is equal to 4 years. Because when you punch this into a calculator, the closest whole number is 4. So you round that up to 4 or round it down depending on what you get as your final answer. Fine. Now, Mpho is granted a loan under the following conditions. We are on 6.3 now. Okay. So the interest rate is 11.3% per annum compounded monthly. So immediately that tells you we divide by 12. The period of the loan is 6 years. So n is equals to 6 times 12. The monthly repayment on the loan is 1,500 Rand, which is X. And the first repayment is made 1 month after the loan is granted, meaning if we are looking for the number of years, at some point we are going to minus by 1. Okay, so you will see what I mean with the minus 1 when we get to 6.3.2. But now let us calculate the value of the loan. 6.3.1. In calculating the value of the loan, we are going to use the present value formula, okay? Now, we know that the present value is given by x into 1 minus 1 plus the interest to the power minus n divided by the interest, right? We don't know what the present value of the loan is. We don't know how much the loan that Mpho got is. And that is what we are trying to figure out. Now, we know that X is 1,500 Rands because Mpho is supposed to make monthly repayments of 1,500 Rands. 1 minus, the interest is 1 plus. What is the interest? The interest is 11.33%, that is 0.113, divided by 12. Because remember, it is compounded monthly. And finally, N is minus 72. All of that divided by 0.113 over 12, and your final answer will be 78,173.49. Okay, great. Now 6.3.2 requires that we calculate how much interest will Mpho pay over the first 5 years. Okay, so the first thing we need to do is we're going to need to calculate the balance of the loan that she needs to pay back after 5 years, right? And after doing that, we will minus that amount from the principal amount of the loan, and then from there we will get how much the interest is. So what we're going to do is we're going to start out with the present value formula, which tells us that the present value is equal to x into 1 minus 1 plus I to the power minus n over I, right? So we know what x is. X is 1,500 Rands. We know what the interest rate is. The interest rate is 0.113 divided by 12. And we know what n is, right? In this case, we were told that the period of the loan is 6 years, but we are looking for how much interest will Mpho pay in total over the first 5 years. Okay, so we're looking for how much in interest Mpho is going to pay over a period of 5 years. Getting right into it, we will substitute in our 1,500 rands. 1 plus the interest rate, 0.113, divided by 12 to the power of minus 12. Okay, so then from here, we'll thus come back and have that at the end of this. Oh, sorry, I forgot to substitute in my interest. And from here, we find that Mpho pays an amount of, the balance after 5 years is 16,945 and 629.629, okay? So, and that is the balance after 5 years, right? Now, from here, what do we need? We need to find out how much in total has Mpho paid in the 5 years that Mpho has been making these installments, okay? So we know that amount paid after 5 years, okay, is 1,500 rand multiplied by 60, which is equal to 90,000. Okay, don't mind this 12 right here. This is just a factor. This comes because we are taking how much Mpho is paid per year, essentially in essentially just 1 year here. Okay, so don't let that scare you. We're just calculating based on what the interest is, based on the fact that the interest is given as compounded annually. Okay, compounded monthly, sorry about that, compounded monthly. And because we are going to calculate the amount that Mpho pays after 5 years, we don't necessarily need to use n being equal to 6 times, 5 times 12, which is 60, because that is accounted for in calculating the amount that Mpho pays in 5 years, okay? So finally, the interest that Mpho pays is going to be the amount after 5 years, okay, minus the loan amount minus the balance of the loan, okay? And that is going to be 90,000 minus 78,173.49 minus 16,945.00629, and your final answer will be something to the likes of 28,771 and 51 cents. So that is the amount of interest that Mpho pays after 5 years. Okay. Now, there's a different method that we could use for this. Okay, there's a different method that immediately just plugs in what the balance is. But then it's a bit of a tedious practice, because in calculating the balance using this method, you need to first use the loan amount itself. So you need to understand how much the loan will be how much the loan will be in that 5 years, right? And you also need to minus the amount of installment that will be paid in 5 years. So what I mean is we take the loan amount, right? Because remember, loans gain interest over time, right? Loans gain interest over time as you are paying them. So we first need to find out how much the loan amount will be after a period of 5 years. How much interest will it have accumulated after 5 years? And from that value, we need to subtract the amount of money that Mpho will have paid into the account over a period of 5 years. So let's do that. I just want to show you how to do it in a different way. So what you're going to do is you're going to say the balance is equal to, right, the loan amount, 78,173.49, multiplied by 1 plus 0.113. Yes, it's 0.113. Let me just double check that. Yes, it's 0.113. Wonderful. Divided by 12 to the power of 60, because remember this is over a period of 5 years, and 60 is equal to 5 times 12. Okay. Now this is this expression here will give you, let me just use a different color. This expression here will give you the amount of interest that the loan gains over a period of 5 years. Okay, it'll tell you the value of the loan in 5 years, and you minus that. Okay, let me just write that down. How much interest has the loan gained in 5 years? Okay, so this amount right here is how much interest is going to give you how much interest the loan has gained in 5 years, by essentially giving you how much the loan will be in 5 years. Okay, so from there we have to minus the amount of money that Mpho has paid into the account over the period of 5 years. Okay, so that's going to be using the future value formula. It's going to be using the future value formula because remember, Mpho is making deposits into an account. Okay, I know it can be a bit confusing when you use this step, because immediately when you hear the word loan, or immediately when you see the word loan on your question paper, you're going to think present value. But in some situations, like in this particular situation, you would have to use the future value, because you want to know how much Mpho will have paid into this account in the future. Okay, we're not trying to figure out how much the loan is right now. We're not trying to figure out how much the installment is going to be if we have taken a particular loan at a certain time. Okay, we are trying to find how much the installments have accumulated to over a period of 5 years. I'm saying a lot right now, but I'm just going to write that out, and using our present value, our future value formula, 1 plus 0.113 divided by 12 to the power 60, because remember, n equals to 5 times 12. And minus 1 right there, divided by 0.113 over 12. And I will call that how much Mpho has deposited into account at end of 5 years. Okay, and these two values will simplify to a balance of 16,945. You find that the amount that Mpho pays, over a period of 5 years is still the same, and that's 90,000 rand. And finally, the interest is given by this formula right here. Okay, so essentially you find the same steps, but in a shorter way using this formula. Although it's shorter, it's a bit more complicated, and it requires some bit of thinking. Okay, it requires some bit of thinking behind it, But if you use this first method that I presented to you, it should be fine, because I feel like this is much easier to use. This method is much easier to use. So you'll choose whatever is comfortable for you. And, oh, wow, we're done with question 6. Okay, cool. I'll just erase that so that we can get started on question 7. So, question 7 is a calculus question, one of my favorite topics. Question 7. Determine f prime at x, which is the first derivative, from first principles if you are given that f at x is equal to 2x squared minus 1. Okay. Now, 7.1, we are told that f at x is equal to 2x squared minus 1. Okay. Now, our formula for the first derivative tells us that f prime at x must be given by the limit as h tends to 0 of f at x plus h minus f at x divided by h. Now, those of you that are interested in math like that, you can go onto YouTube and find out why we use this particular derivation, because I know your teachers really don't give you much of a reason for why we use this formula. But it's a very interesting derivation and it's fun, so try it out on YouTube. Just look for derivation of first principles and you should be fine. So here we are told that we need to look for f at x plus h, right? So what is f at x plus h? What f at x plus h essentially means is wherever in our original equation we see an x, right, we substitute in x plus h. So how does that work? We're going to say that f at x plus h is given by 2 into x plus h squared minus 1. Minus 1, okay? And if we expand that out, we will have something that looks like this. Okay? Expanding that out, we get 2 into x squared plus 2xh. Okay, let me write that in a nicer way. Plus 2hx plus h squared minus 1. And that will finally be 2x squared plus 4hx plus 2h squared minus 1. Now, what we're going to do is we're going to take this and substitute it into our formula. And when we do substitute into our formula, what do we get? We get that when we do substitute that into our formula for the first derivative using first principle, we get that f prime at x is equal to, what is f prime at x equal to? F prime at x is equal to, we substitute in that is going to be 2x squared plus 4hx plus 2h squared minus 1 minus the entirety of f at x, okay? Minus the entirety of f at x. So here we substitute in this 2x squared minus 1. So we're going to use our bracket 2x squared minus 1. And what that's going to do is it's essentially going to change the sign of whatever's inside the bracket such that we have minus 2x squared plus 1. And we divide all of that by h. I forgot my limit. Please don't forget to write down your limit. This is very important. Without this part of the expression, you will not get any marks. It's actively imperative that you have the limit in front of your expression, okay? So from here, immediately you can tell that 2x squared and 2x squared cancel, minus 1 and positive 1 cancel, and you are left with 4hx. You're left with 4hx plus 2h squared over h. Now what we're going to do in the next step is we immediately going to factor out the h, right? Because it's a common factor. So we factor out the h and we're left with 4x plus 2h, okay? And that's going to be divided by h. And presto magic, h cancels it out. And from this step, what you're immediately going to do is you're going to substitute the limit that h tends to 0. Okay, so when we substitute in the limit that h tends to 0, what we mean is we just, wherever we see the h, we're going to substitute in the number 0, right? If it was the limit as h tends to 1, it would mean that wherever we see an h, we plug in a 1, okay? So don't let that confuse you. It just means that when you get to the most simplified form of your expression, you just substitute in 0 to find the first derivative. So that's going to be 4x plus 2 into 0. Now, you need to see here that I did not have the limit as h tends to 0 in this step right here, right? And the reason for that is because I don't need to write this anymore because I've substituted in what 0 is, okay? So I don't need to have this limit right there. And so that is the beauty of derivation or differentiation from first principle. And now going into a power rule question that assesses your proficiency in your power rule. So we are told to find d by dx of the fifth root of x squared plus x cubed. Now, laws of exponents tells me that if I have a, the eighth root of x to the power m, this is the same as writing x to the power m divided by a, okay? So what this means is that d by dx is going to be equals to d by dx into x to the power 2 over 5 plus x to the power 3, okay? And then from here, because this is a binomial, what we're going to do is we're going to take this d by dx and multiply it into the bracket such that we have d by dx of x to the power 2 over 5 plus d by dx of x to the power 3. So you need to understand that the differential operator is commutative. It can multiply into the bracket to act on whatever function you are trying to derive, okay? It does have additive properties, which is why we are able to distribute. It has additive and distributive properties, which is why we are able to distribute the derivative operator into our expression, okay? So then for the derivative of x to the power 2 over 5, we have that is 2 over 5x to the power minus 2 over 5 minus 1. That's 2 minus 5 over 2, that's minus 3 over 5 plus 3x to the power 2. And that will be your final answer for 7.2.1. And finally, 7.2.2. We have that f at x is equal to 4x squared minus 9 over 4x plus 6 if x is not equal to minus 3 over 2, okay? So there's two ways to approach this question, okay? The first way is you would simplify what this expression is and derive at the end of and start differentiating at the end of the simplification. Another way that you could do it is you could use the quotient rule, which immediately just gives you the derivative from the get-go, although it is a bit more rigorous in how you use it. It's a bit more hectic, okay? So we're going to start with the method where you just have to simplify, okay? And in simplifying, let's say option 1. In simplifying, you have that f at x is equal to... Now, what you need to notice here is that right here is a difference of 2 squares, okay? Because you can write this as... You can write this expression right up there as 2 to the power 2x squared, or you could write that as 2x all squared minus 3 squared. So this is a difference of two squares, and because it's a difference of two squares, it means that then we can write it as 2x minus 3 and 2x plus 3, okay, divided by, when you divide, let's look at what is a common factor that we can remove from our denominator there. The common factor is 2, and if we remove the 2 there, we are left with x plus 3, sorry, 2x plus 3. Immediately you can tell that these two cancel each other out, such that you are left with 2x minus 3 over 2, and that simplifies to x minus 3 over 2. So from here, the first derivative would then be d by dx of x minus 3 over 2, and that is just equal to 1, okay, because the derivative of a constant number is 0 and the derivative of x is just 1. The second option you could use, option 2, is you could decide to name your functions, okay, by using the quotient rule. So the first thing we're going to do is we're going to name our functions. We're going to let g at x be equal to 4x squared minus 9, and let h at x be equal to 4x plus 6, okay? Now what the quotient rule tells you is that the first derivative, right, if you have a function, it tells you that if f at x is equal to g at x divided by h at x, right, then the first derivative of f will be given by the first derivative of g multiplied by h at x, okay, this is a multiplication, minus the first derivative of h at x multiplied by g at x divided by h at x squared. All right, now moving on, we find that the first derivative of g at x, g prime at x, is given as 8x, okay, so that's going to be 8x multiplied by 4x plus 6, because that is our h at x, minus h prime at x. The first derivative of hx is just x, okay, so this is going to be minus x into 4x squared minus 9. No, this is 4. This should be 4, not x. Please excuse that error. Into what g at x is, that is our g at x, divided by 4x plus 6. Let's just write that out in expanded form, 4x plus 6, and that's 4x plus 6 squared. This will thus be equal to 8 into 4, that is 32. 32x squared plus 8 into 6, 6 into 8, 16. So that will be 52. I just need to find my calculator to make sure that I am doing the right thing. 8 times 4 is 32, and 8 times 6 is 48, not 52. That will be 48x, right? Minus 16x squared plus, what's 4 times 9? 4 times 9 is 36. All divided by 4x times 4x, that's 16x squared. 4x times 6 plus 4x times 6, that's 4 times 6 times 2, that's 48, plus 48x, and finally plus 6 times 6, that's 36, right? Simplifying the numerator, you find that 32x minus 16x, that will give you 16x squared plus 48x plus 36, divided by the denominator 16x squared plus 48x plus 36. And your final answer will be 1. And ladies and gentlemen, that is it for our session. We will continue with question 8 later.